Okay, so let's talk about horizontal scaling and the situation where you deployed your applications on the clouds, and when our applications are receive requests from the different location, different geolocations, right? And our system is perform as per expected. All the requests are taken by our server. But sometimes suddenly we observe that our request is come, our request traffic is going to suddenly increase. Okay, so our system should be handled and capable. So those scenario, if let's initially our one server is sufficient to handle, let's about the thousand of requests per second, it's good. But suddenly our applications are going to increase the request traffic to the millions of users. So surely once request is not able to serve the request. Why? Because they are going to serve, so might be lots of requests go in the queue, and each request response would be the delay. So we don't want our system are going to reduce the performance when the request traffic going to increase. So what the good options? Let's scale my system. That means instead of only one server, I can add one more server, add one more server, add more server. Now all the user requests are diverted to the different server. That means now we are going to distribute our user request to the different server. Now our service, our systems are responsive as previously. So each and every customer feel, hey, now our application performance is as expected as before. Even the one specific customer or user don't know at this times how much number of request is served by the system. From the individual user perspective, I am just sending a request. My expectation, I am getting a response. But from the system point of view, at the same time, system can receive the millions of requests. So might be one server is not able to, if it effectively responds, then we can say we can distribute the user traffic to the different number of server. So this concept is uh, scaling our system capacity. This is known as a horizontal scaling. Okay, and some other key benefits we can get if we are going to scale our system horizontally. Okay, so let's talk detail about the horizontal scaling, or you can say scale out. So generally, whenever Tom's talk about the scaling up or scaling out, today we are going to talk about the scaling out. Scaling up means we have only one server that's serve the my request. If user traffic request, I'm going to add more number of CPU, more number of disk. Previously three and two, now add more CPU, or you can add more disk. So this is known as a scaling up. But in the case of scaling out, we have, let's see, we have a two nodes that's serving the request. So instead of, I can go add one more, add one more, add one more, add more one. So any number of server we are going to add, so that whatever the user traffic coming, we are going to distribute the user traffic into the different server. So in this way we can meet the our system performance, and our system is now capable to handle millions of requests, because now our load is distributed to clusters of servers. So, as for the definition about this horizontal scaling, as you know, horizontal scaling, also known as a scaling out, that's it is a technique to increase the capacity of system by adding more resources. Resources like a server, nodes, or instances in the existing infrastructure. So objective of our horizontal scaling, adding more server. Why? To increase my system capacity for handling user traffic. So this approach allow the system can handle increase the traffic workload or the demand without compromising the performance. So here objective horizontal scaling say we are going to handle system is going to handle if the request work are going to increase or user traffic going to increase or some demand of high request, our system can handle and without compromising the performance. That means the individual user cannot feel any kind of performance degrade if our system receiving high user traffics. This horizontal scaling help to meet this requirement. In a horizontal scaling, these are the basic concepts. So whenever you are going to add one server, more server, more server, more server, okay. So question that so request comes, how request decide on which server I am going to do. So surely we need a kind of a load balancer. So one new layers introduce whenever you are going to increase your system capacity by introducing the load balancer. So load balancer responsibility, all the customers are just reaching the load balancer and load balancer know the clusters of nodes which they have and now they are distributed the to the different nodes. So here load balancer means distributing incoming traffic across the multiple server to ensure no single server is overwhelmed, right? The objective of load balancer, distribute load across among the nodes. So what is the nodes? Nodes is a single server or instance that provide the specific functionality. So whatever the user request for the particular service, those service is a install on a particular server you can say or node you can say. And what the cluster? Cluster means the group of nodes that work together to provide the shared services. So here instead of one server we have a groups of server. The groups of server can, you can say the cluster, maybe cluster multiple clusters you can create. And here scaling terminology might be increasing or decreasing the number of nodes. So let's keep in one cluster. In one cluster, we have a node 1, node 2, node 3. Our application properly using the load balancer are able to handle all the requests. But suddenly load balancer decide, hey, the user request going to the increase more and more. They are going to request, hey, add one more server, add one more server, add one, so that the load balancer can distribute the user traffic to the different server, right? But sometime might be now our after some time or particular 1 day or 2 days, load balancer decide, hey, now the user traffic is as normal user, might be you don't require more nodes, so can you just move out. So here scaling means increasing or decreasing the number of nodes in the cluster to match the our load or work demands. And so in the basic architectures of load balancing, about the sorry, in the basic architecture of scaling out means horizontal scaling, there would be your load balancer, one the load balancer component, and another is the your clusters of node, clusters of node are the instances or server, and the client are requesting to your load balancer. Load balancer distribute call to the multi instance of the nodes, and one more component required the node management. Node management know to inform the, hey, load balancer, these are the list of nodes available to serve this request. This load balancer with the help of a node manager, is responsible to monitor the health of every. But let's keep particular nodes are going to very high CPU usage, are very low memory, so they are going to add one more server, add one more server. So you can say monitor the health and add or remove nodes as needed, ensure the cluster is balanced. So for managing the clusters health monitoring, we need a node management. So generally in the high horizontal scaling, we have a load balancer, we have a node clusters, and the node management. Node management is the monitoring nodes to health, and as per the application need, they are going to add more nodes, or if needed, they are going to remove nodes. So whatever they are going to add node or remove node, node management also going to update the load balancer. So load balancer know these number of steps, these number of nodes are really active, so that key node balancer can distribute node to the multiple server, right? So this, whenever we talk number of servers are scaling out or scaling in. So scaling in is we are going to add more nodes in the existing cluster. That means scaling out. Scaling in is means removing nodes from the cluster. That means scaling in. So depend upon the our user traffic load, our node management decide कि I am going to add more node in the clusters, more node in the clusters, or we can going to remove some node from the cluster. So this is the scaling out and scaling in. And this is the one more concept, very, very powerful, auto scaling. So scaling out and scaling in, is it not possible? Our system can automatically decide. So auto scaling is a feature. Auto scaling automatically adding or removing nodes based on the workload demand. So whatever workload demand currently have, according to the load balancer analytics, we can our system can automatically find out, hey, now we need to add more server they request. On the runtime, new servers are prepared and associated, and sometime our auto scaling also, hey, now there is no more server needed, unnecessary extra server is not required, they remove as well. As so generally, or scaling out or scaling in, or you can combine say auto scaling is the basic types of your horizontal scaling. And these are scenario use cases where generally we are thinking to apply horizontal scaling. E-commerce or the website to handle increase the traffic during the sale periods, or maybe your social media platforms where managing growing user base and user activities. So in this case, if your user base going on, we have to manage, then we have to increase our system capacity by horizontal scaling, adding more application server, more database server, and the real-time analytics, processing large amount of data from the various sources. Sometimes we are building analytic application, they are receiving different sources, lots of data. So these, if you are going to manage process huge volume of data, so one server or one database is not more capable, then we need to scale out my system so that we can provide the real-time analytics to the user. Even nowadays, all the gamings provide a smooth gaming experience for the large number of user bases. So here also a very good scenario where we are going to make our system horizontally scale to meet this gaming experience to all the users. Whenever you can increase your system capacity with the help of horizontal scaling, if in this case we can get some more benefits. One thing surely we can increase our system capacity so that our systems are handle more traffic workload and whatever the demands of the my systems. And In this way, if we are adding more server, that means ki our application are more become a improved performance, because now each and every servers are going to respond as quick as possible, because that they have a our load balancer distribute load among the multiple servers. And with the help of horizontal scaling, our system by default become a highly available, because we have a lots of server available. Requests can be routed different, so maybe one server somehow down, still lots of other servers available. So you can say our system is become very highly available. So you can say reduce the downtime and improve the system reliability. Even some setup server going to down, no problem. We can add more server. We can add more server, and distribute the customer load to the different new server. Okay. So in this way, increase the capacity, improve the performance, high availability, even with the help of nowadays the cloud provider, we make a cost effective system. So when we need lots of server, then we add more servers, right? And we serve. If sometimes there is normal load base, we can just remove the server, remove the server, remove the server. So on the basis of our demand, we are using the more server, and sometimes there is no demand, we can just remove out our server. So we have to pay to the cloud provider only for those resources which are really our system using. So auto scaling is the almost all the cloud providers provide the facility automatically add server and automatically remove server if they are not needed. Okay, these are the some challenges whenever you are going to add more server. So then we ensure that our networking, if efficient communication between the node happen. What happens if your data, you want to sync data from here to here to here to here? So this is a problem of the data consistency as well as. So whenever you are scaling out more servers, so might be chances you have to lose your data consistency. For those, we have to put proper maintain the data consistency across the nodes. So we have to put extra effort and intelligence, ensure that our communication between all the nodes happen effectively and data is consistent across the nodes, because now our load balancer can load to the different server. Each server must have those data available. And sometime whenever you are going to scaling out system is scaling out, we have to also ensure our the scalability scalability limits. The horizontal scaling may reach its limit, then it requires some level of your vertical scaling or alternative solution. We have to think how we, when our system meet the scalability issue. So this is the very rare chances. Nowadays the cloud providers are providing very high scalable system nowadays, right? A good options for this high scalable system, you can say horizontally scaling system, we have already open source and commercials are cloud providers available as a technology. Just we have to decide, hey, what the load balancer you want to use. Let's use your HA proxy, nginx, yeah, Amazon elastic load balancer, Google cloud load balancing, yeah, Azure load balancer, even say. So lots of load balancer technology available, we have to just use and configure them. So load balancer, you can after that you need the actual instance server clusters where your application is running. For those scenario, you can use the containerization systems where you can maybe use the Docker, a Kubernetes, a Red Hat, OpenShift, Apache. So these all provide the containerization systems. And even combined thing, you can want to cloud provider all offer everything. You can offer, they offer for instances use, they offer for server use, they offer for databases, and you can just configure them the load balancer. So you can go to the AWS cloud or Google cloud, Microsoft cloud, IBM cloud, Oracle cloud. Lots of technology or cloud provider nowadays offer this horizontal scaling, yeah, increasing your system capacity out of your technology. And even you can also think auto scaling tools. Maybe AWS also have auto scaling, Azure have a auto scale, Google have a auto scaling, Kubernetes also have a concept, Docker also auto scaling. Lots of technology we have an option. You can apply auto scaling so that key depend upon the our user traffic, the on demand, the number of clusters nodes are added in the clusters, or if required they are removed from the cluster as well. So whenever you are going to the managing large number of clusters, you notice LinkedIn or Facebook, they have 100, more than 100, more than 200 clusters are scaling out the system. So those kind of things we have again need to monitor all those devices, which are healthy state, which are the not healthy state node, which are the going to the full, we need to add more server or we need to remove the server. So for this we need some kind of a monitoring and logging tools. You can use Prometheus, Grafana, ELK, Elasticsearch, Logstash, Kibana, Splunk, New Relic. Lots of tools for monitoring your clusters we have. And you can also, maybe you can use the orchestration tools as well as you can use the lots of tools and technology available. So you can say these are the technology already have, we have to just choose them as per our need. And good example, all this technology are already used by the industries. So we can rely on that. Big player nowadays talk about the Netflix or Amazon or Google or Facebook or LinkedIn. All these big players are using these architectures. Like for example, Netflix. Netflix use the microservice architecture with a horizontal scaling to handle high traffic and high user growth. Even also, Amazon employ the horizontal scaling to manage the e-commerce platform even during the your high peak traffic days. Google also uses horizontal scaling to power its search engine, handle millions of requests per day, right? So even Facebook also use this scale its social media platform horizontally to accommodate massive user base and activities. LinkedIn also use the horizontal scaling to manage its infrastructure to high uh, traffics. So the lots of big player already implemented horizontal scaling, and nowadays all the cloud providers with the help of horizontal scaling they are offering the services. So we can rely them and then we can use them this as well as. These are the scenario where you can think, hey, the horizontal scaling must be needed. Maybe some e-commerce websites are going to declare some the Black Friday sale or some event activities. So in those times, the normal days, the number of request systems serve is highly increased those days. So for those, our system must be scalable so that they can handle the high traffic user on a particular sales day, right? So we our system must be designed such way. Maybe some companies are going to the launch some new product. So whenever custom company announce some new product, at that time, lots of new types, lots of users, suddenly the user traffic is going to increase on my system. So my system must be able to handle and be responsive for to handling the high traffics on my system. So horizontal scaling help us to maintain such systems and handle our system with the help of horizontal scaling are able to maintain performance, and the system is capable to handle the high increase user traffics. Sometime you can go social media campaign. Lots of nowadays social activities going on. Some government event, non-government events, some games, some big event happening. So nowadays on the social media, marketing campaign going on nowadays so viral. So during that days, our website received the high traffic volume. So our website, our system must be in a position so that they can scale our capability, so accommodate all the increased traffics and the demand. Okay, so our horizontal scaling is the one of the powerful tool for the system design engineer. You can designing a system and commit to the customer. Our system is in the position to handle the load, maybe on demand, conditionally, particular situation come. Our system have a lots of intelligence. They can automatically increase its capacity and serve the user request. Now, after some time, some days, some week, there is no such high traffics observed in the system. Our auto scaling feature automatically pull out those servers that are really not needed. So you can say horizontal scaling with a cost effective manner, we can design our system. Okay, so the lots of you can say content available on the internet are go. Just I read out the aws have exposed a very very concise detail about the scaling, what are the scaling, how aws ensure scaling. If your user increase the 10k user, then how to handle. If your user base going to is 500k, 1 million k, 10 million k, then how you can handle. So these are the, just go and read and understand. You should understand. The problem is that here our as a system design engineer, our objective, we should aware how we can manage, our system can handle the on demand user traffic on my systems. Okay, so let's talk about the AWS. AWS is a very good detailed documentation available. They are ensuring that you can design the system are very very scalable, highly available, you can say. And for those, they are whole our geolocation, they are deployed the multiple data sensor. There are some data center here, some data center here. So notice the all the servers are across the geographical location there. And even whole this our earth, the aws is divided into the regions. So this is the region, these are the regions. In each region they have a different data center, and in each region also they have a concept of available zones. So availability zones, so each region have a availability zone, and in availability zones you can just, hey, this is the